we have this webcam and this webcam hooked up, and then we also need the PowerPoint to be hooked up. So it should. Yeah, so that should. So the PowerPoints are now up. So PowerPoint up, that should be good enough. Right. Okay, up to you guys. All right. So let's go ahead and go through our agenda for today. We're going to talk a little bit about the robotics team, what we do, what kind of things we do, and then talk about upcoming events for our robotics team, and then we're going to let our generous generous guest speakers come in and talk about their company, Rugged Robotics, talk about what they do. Come on in, Dixie. Talk about what they do, how to get more involved with the company, and also give us a live demo of their robot, which they're setting up later. So, a little bit about the robotics at UH. The Robotics at UH has the mission of the proliferation of robots across the city of Houston, not just at UH, but also at Rice, at HCC, UH Katy and HCC Katy, and across Houston as a whole. Robotics at UH takes a lot of other formal organizations, mostly university drone pilots and IEEE's robotics organization, as well as a couple of other student orgs, and merges it into one major robotics-only and robotics-focused student org, right? We also have a couple of competitive robotics teams that we'll talk a little bit more about in detail. As we've just mentioned, there's our officers, Justin, me, and Will. We also have Malik, who forgot to submit his photo, so he's Jeff Bezos, along with John, Aaron, and Jay, who are the team leaders for our sub-teams. Our sub-teams are focused on teaching students new skills, new abilities, and as well as get them into a competition or some sort of research-based focus. Malik, John, you guys want to talk about Battlebots real quick?
Yeah.
Yep.
Well, we spend a lot of time building robots, and then we smash them to bits against each other, and it's a lot of fun.
Yeah. So that is the current designs that they both have right now. Do you want to talk about them?
This is John's, this is mine. Mine's basically, so far, I'm going for a spinner bot. I've got one passive wedge, and yeah, I just really hope to rip the other opponent to shreds. So
800 PSI CO2 powered rocket sled. That's all you need to know. It's going to be awesome one way or another. Something's going to explode.
All right. Well, that's interesting. Thank you, John. All right. We also have our new search and rescue team, which is just being set up now. Jay is in charge of that. Jay,
so basically, it's just to establish the use of heterogeneous robots, which is like different types of robots, in order to which is fused together for one particular application. So for here, we're going to use like drones and ground robots and whatnot for the use of search and rescue. And it's going to be a collaborative project with Code Coops, which is another organization. They're going to be helping us with the coding aspect of this particular project, and it's going to be a pretty interesting one. It's going to extend until next spring, hopefully, and hopefully by the end of this next semester, we'll be able to demonstrate a successful a demonstration of how search and rescue operation works. So that's all about this one.
Our search and rescue team is backed by Texas Search and Rescue Organization, so TXAR, Gulf Coast Regional. They have been supporting us kindly for that. So we supported them last year in a search and rescue event out in Tomball, and we're hoping to do that again starting in spring to actually provide them with the capability to search and rescue. So thank you, Jay.
Yeah,
all right.
And we are currently recruiting team members for this particular project. So anyone interested could message me on Discord, or even we can talk after the meeting.
All right. Okay. So for upcoming events, we had a lot. For those of you who were here yesterday, you guys, if you guys didn't see it, you guys saw our first Autodesk workshop. We've got another one with Autodesk coming in and teaching us how to do Fusion 360 coming up on October 27th. The room is supposed to be the same room, SEC room 105. They may switch it up again. We'll let you guys know as we go. But if you guys have any questions, check the Discord, check the Teams, and if you want to sign up, RSVP using the QR code, scan that, and it'll give you email updates for more information, right? We also have, wow, thanks Justin for, the images have unloaded themselves apparently. So, thank you. So, we have 3 upcoming events coming up. We have a tour with Nauticus Robotics, who was formerly Houston Mechatronics. Their specialty is underwater robots. We'll hopefully, in late October, be going out to the facility, doing a tour of their facility. So we'll all get in a car from here, drive over to their facility out in, where is NASA centered? League City, Texas, and see their facility, which would be really cool. We're also going to have a drone workshop with the American Society of Civil Engineers. We're going to be mapping the engineering building from the outside and creating a 2D map of it so that they can do some fun stuff with. We've also got, as Malik and John have been very worried about, our first competition. Battlebots teams, our first competition is November 5th at the Ion. All of this information and our slides will be up. All of this information will be up on our Discord, so if you guys haven't joined that yet, please take a look at that. That comes for most of our updates. I would now like to turn it over to George and Logan to talk about Rugged Robotics. Everyone, please give them a round of applause. Do you want to send me your slides and I can put it up here?
Can I just plug in via HDMI
Sure.
or something?
Yeah. It won't show up on the stream then, but it'll be fine.
What?
It won't show up on the live stream, but it'll be fine.
Okay.
Yeah. Here you go. HDMI.
Thank you. Oh, jeez.
Yeah, you've got a full webcam set.
Howdy, y'all. Thanks for having us, and thanks for giving us your Friday afternoon. I know it's late in the day. It's almost the weekend, so appreciate you carving out time for us to give our presentation. My name is George Banos. I work at Rugged Robotics. Relatively new to the team. My background is in construction. I started my career, well, I'll go back to the college days. I went to LSU, majored in construction management. That was in the College of Engineering. Graduated, got a job with a commercial contractor here in Houston doing a number of different commercial construction projects. Started in the field, supervising construction sites, and worked my way into the office doing some of the estimating and project management stuff. I actually, interestingly enough, I taught Introduction to Construction Management here at U of H at the College of Technology. I want to say it was the Annex building.
Yeah.
This was the better part of a decade ago, so it's good to be back. Let's see, I spent the last 12 years in software and then recently joined Rugged. So I have kind of an interesting and circuitous route into the robotics field. It's something I've always been interested in, but I kind of view my role as the interesting intersection between software and construction, and naturally there's a great fit here. I'm going to introduce my partner in crime. This is actually the founder of Rugged Robotics, Logan Farrell, and he'll do most of the presentation, and then I'll get into talking about what my role is.
Cool. Thanks, George.
Yep.
Thanks, everybody. Everybody hear me okay? Is this volume good? Awesome.
Volume good, yeah.
This room's actually pretty well set up. I can hear myself projecting. It's nice. So my name's Logan Farrell, co-founder and CTO at Rugged. I'm gonna move around a lot, so I apologize for the webcam. But really, kind of, I was asked. There's a few different interesting things to share about who I am and what Rugged is doing. You know, we're a startup, seed, Series A, funded startup. So there's been a lot of interesting things in how do you actually start a company. Derek and I founded it 3.5 years ago. So kind of that journey, and there's also the sales and strategy and how are we actually executing now. And then lastly, the technology development of how did we build the robot we did and why. So what we were asked to focus on is really how did we build the robot we did? Why did we build the robot we did? What was that path? What was the development process? What were the steps? So that's what I'm going to focus on, but kind of hitting on some of those other areas. So to start, these next 5-ish slides are literally pulled straight from our pitch deck for our Series A fundraise. So you'll get a little bit of an insight. My plan is to actually give it as if you're a venture, so you can hear kind of what a pitch to try and convince somebody to give you $9-ish million sounds like. It's a wild process to have a meeting with somebody and be like, yeah, I'm amazing. My team's amazing. Give me a whole shit ton of money. So here's how I would start. Hey, I'm Logan. We do a little bit of intros. We'll start with personal intros. Derek would normally say hi, I'm Derek Morris. My background is construction and business. I spent 7 years as a professional engineer in commercial construction. I was on projects all the time doing code consulting in the Boston area. I know these guys. And Derek actually hung sprinkler pipe in high school and college, so he lots of familiarity with construction. And then kind of plateaued in that and wanted to do something different. So went and got his MBA from MIT at Sloan Business School. From there, I did corporate consulting in Seoul, South Korea for Samsung, directly under Chairman Lee. Spent 4 years doing that, but wanted to get back into construction, but more from the business side. How do we solve construction's problems? And that's where he kind of started ideating on rugged robotics, on our thesis, on our first product. And then that's where he met me, and I'm Logan. My background is robotics. I'm the robotics half of the founding partnership. We, so we balance ourselves well for the company we're trying to build. And my background is robots, has been my whole life. I started in first robotics in high school. I was like, I'm gonna build sweet robots for a job. And so far I've successfully done that, which has been pretty cool. I cut my teeth at NASA, spent about 8 years there doing robotics R&D. The first half was mechanical design for rovers. The second half was software development for humanoids, path and motion planning, perception, cognition, high-level task autonomy, that kind of stuff. Before Derek called me up and he's like, hey, you want to solve like real problems that real people have on planet Earth right now? It's like, yeah, that sounds awesome. So, that's how we teamed up. And really what we're trying to do is automate things that make sense to automate in commercial construction, and layout is the beachhead for that effort. Construction needs to be automated. Everybody has a hard time finding labor, everybody has a hard time hiring, everybody has a hard time with all of that just the labor pool is moving into colleges, there's less trade labor, etc. So everybody has this problem. So we need to get automation into the job site. The question is how? We feel that layout is the way to do that. We can start reshaping the industry from this landing point. And you ask, what is layout? Layout is the process of translating the digital model into the real world. At a certain point, you've got a Revit model, an AutoCAD model of where all of these walls go, where all the light fixtures are, the HVAC ducts. This room is particularly complicated. You've got that fancy model of this is how the architect and the engineers want to build the building. And then a group of guys come in with paper drawings, tape measures, and chalk lines to actually mark out how the building gets built. They literally crawl around on their hands and knees using a tool developed by the Egyptians to build the pyramids. So it's like a laughably archaic way of translating this fancy model into the real world. And a room like this would be challenging as hell, because how do I lay out this curve and these like locations and like the curves and the soffits and the ceiling? This is a nightmare in here. So that's the manual process they do now. Error prone, each trade does it individually. Like there's just so many issues with the overall process. And like I said, relies on what the Egyptians did. Literally, it's one of my favorite fun facts about the startup story here. And it's very error prone, and usually you don't find out there's an error until after everything's built and the door doesn't open, or the cabinet doesn't fit, or the ADA clearance isn't correct, and you have to spend $100,000 to tear out the bathroom and do it again. Like that is what happens in the real life right now. So what we have done is build a solution that solves this problem. And what our solution does is cuts down manual layout time from weeks to days. So our robot will drive around on unfinished concrete floors, marking where everything goes down to 1/8 inch accuracy across the floor. At scale, here's some of the numbers we're looking at for manual. We turn 90 days into 9 days. We have the mechanical is the same, 120 days to 23 days. So these are the levels of scale that we're looking at. And from the business perspective, why it's attractive to venture capital is that we can charge the same amount for manual layout that they're doing now. Like that's our end goal. So we're gonna charge for this building. This is 240,000 square feet. We're gonna charge $240,000 to do all of this work in 20 or 32 days at a cost of about $1,000 a day. So if you look at profit margins on the capital side, that's a very, very good number. So that's rugged. That's who we are, what we're doing, and why. Any questions on the actual premise of the company before I dive into kind of how we got to my statement of we can come do this for you, the customer?
So you did FYC.
I did.
What team were you a part of in FYC?
I founded 1747, one of the Purdue-sponsored teams in Indiana when I was a freshman, and then I mentored 118 for about 7 years while I was at NASA.
What year did you mentor 118?
14, well, 12 a little bit, but mostly 14 through 17.
Oh God, I competed against you.
Sorry
That's
about
terrifying.
that. It was fun. It was great. Those are great kids. I love those kids. Any other questions about the company in general before we get into tech and why we did what we did? Cool.
Okay.
So, first of all, this is current day. We have 10 of these robots. This is one of our glamour shots of all of the robots out in the world. We have one of these in the Pelican in the back that we'll pull out and show you guys a little bit later. So we're going to progress towards how we got from 2 guys with an idea to a fleet of robots and the eventual fleet we're going to build. Yeah?
Question, do they have names?
Yes, they do. The colored ones do. They're the Ninja Turtles. Raphael, Donatello, Leonardo, Michelangelo, and then the yellow one is Jenica, which per Teenage Mutant Ninja Turtle lore, Jenica was the first 5th Ninja Turtle per the comic books. The movie with the 5th Ninja Turtle actually came out before, but according to like diehard TMNT folks, that is not true. So Jenica is actually the first 5th Ninja Turtle. Yeah, deep. The next one is just called 406.
The black one?
Yeah, well, it's 406, 407, 408, 409, 410. Lame. So how do we go from, how did we get here technologically? At one point it was Derek and I. And so how did we actually do it? This was the first robot, the Alpha robot. You can see it driving around in my garage. We had started trying to raise money for this idea before we built this robot, and it wasn't going great. People were like, oh, I kind of get it. Like, we just couldn't get traction with VC. So we built this little machine, 4-wheel drive, 4-wheel steer. This is the concept we were going after, the design, but in like super cheapo parts floated on credit cards. And we filmed this in my garage one night at like 9 p.m. to 3 a.m. The day before flying out to LA for more meetings with Venture. And we started showing this video, and this video is really what got us $2.5 million to get things off the ground. It was this super simple, dumb robot where we were able to kind of just show the general concept of what we're trying to do. So this is laying wall track for some small room in Logan's garage. So kind of my point here is that we spent $6,000 to make $2.5 million, but the important part was that the folks we were trying to convince, effectively our customers were venture capital, and they needed something physical, something tangible to wrap their brain around what we were trying to do. It wasn't until we had that physical thing that got them over the hill, but that physical thing was pretty simple. It didn't need a lot, but it needed something. So that's, really it opened up the door for us. And this kind of set up some of the basic, we set up kind of our initial controller, so a simulation environment. So we got kind of software, tools and assets off the ground, not like a ton of super developed, complicated stuff going on in here. But this was what unlocked the seed round of funding. So then what did we do next? We built our first metal robot with the goal of failing fast. And that's something I tell my team all the time, is the only thing you know about a prototype is that it's wrong. We're on our 5th level of prototype, and it's also still wrong. We're about to build our first commercial unit. First one of that's going to be wrong, but it's just the goal is to have fewer and fewer things wrong. But I knew going in, the first one's going to be super wrong. So let's just build it as fast as we freaking can so that we can learn those lessons and move on. So it was me and an intern, actually a student from U of H who worked with us, Mary, for, I don't know if everybody knows Mary Wynn, but she worked with us for 9 months. Basically, she and I put together this first robot, designed and built in 3 months between the 2 of us. It lived for exactly 2 months before we decommissioned it for the next robot. It was super quick. Basically, the first 5 times we drove it around, we knew, okay, this is wrong, this is wrong, this is wrong. So like that was the purpose of this robot, was fail fast. So you can see, some of the details here. You got 4-wheel drive, 4-wheel steer, a lidar on top. We're actually powering it using DeWalt battery packs, which we're still doing today. So there are pieces of this robot that still exist. There's the core electrical system. A lot of that still exists on the current robots. So there were pieces we got right, but there were also pieces we got wrong. Kind of moving to
Using holonomic drive?
Yes, full holonomic. So because we have the caster offset of the wheel, we can move any direction from any direction. So I can drive and twist and turn in any orientation we want. So a high level of controllability, and I'll get to some of the nuances of how it helps us in the field as well. But you can see, robot drive around slowly. We thought we were such hot shit at this point doing this stuff. These marks on the ground, this is actually the way we were kind of localizing. So we're using fiducials with the camera looking down saying, where am I compared to where I'm supposed to be? This is how we were error checking. At this point, we couldn't drive in this 9x9 square and end up remotely back over our starting point. And reminder, the goal is to build a robot that's an 1/8 inch accurate across a 40,000 square foot floor plate. So being able to not drive 9 feet and end up where you meant to was a problem. But it was more like, solve things as they come and as they make sense. I can't start solving accuracy until I have a robot to try and be accurate with. Yeah.
For those of us who don't know, what is a holonomic drive?
Holonomic it's the technical definition of a robot that can drive to any orientation from any orientation. So from any orientation of these robots' wheels, I can drive this way with a 30-degree twist, or directly to the left, or directly down with no additional motion because of the geometric structure of the wheels. Did that explain it well enough?
Yes, thank you.
Yeah.
Crab walk.
Some of the things we knew were wrong. This had the actuator, a belt, and then the drive. Tons of problems. We couldn't tension the belt well enough. It had initialization issues, just a bunch of headaches. So that was a big one. We didn't have enough internal volume. The structure of the chassis wasn't quite like we liked. The way the LiDAR was sitting wasn't quite like we liked. We accidentally built a Faraday cage the first time we put it together. I turned it on and I couldn't talk to it. I was like, what the hell? And I take the top off and I can talk to it. I put the top on and I can't talk to it. It's like, right. I put the Wi-Fi in the metal. Damn it. So that's why there's that giant antenna sticking up out of the back. We just literally drilled a giant hole and popped the antenna through. So we actually almost made that mistake again very recently because we forgot the lessons we learned. So, like I said, we built that robot quickly and killed it quickly in favor of the next robot. So this is beta 2. Development time with a larger team, still 3 months, so still whipped it up pretty quickly. Electrical system, pretty much the same, but the main difference obviously is this rat's nest of wires and the print system. So this print system is how we actually mark the ground for where the drywall needs to go, where HVAC ducts need to go, and it's part of the reason for the holonomic drive. The printer, we want to be able to put it right up next to, let's say I want to mark where that panel goes, I need to be able to put the printer pretty much right up next to this stone wall and still be able to print that feature. So having holonomic drive allows us to duck that print head deep into the corner. So this was the first robot that actually printed. The main technology kind of software development was actually integrating the printer, being able to talk. We basically backdoored a commercial printer. We looked at building our own and we're like, that's dumb. Lots of people build really good printers for production lines and all kinds of stuff. Why don't we just buy one of those? So I found one that had enough stuff that we could backdoor, and it's actually kind of funny. I still, we talk to them all the time, and they'll just send us stuff. They're like, yeah, you guys know what you're doing. You can figure it out. You guys are the most super users we've ever talked to. It's like, well, it's probably because we're the only roboticists using your system. These are designed for printing ASTM 1722 on black pipe, not for backdooring by a robot. So one of the big thing with this was integrating the printer and actually starting to print features and trying to understand. And we're still, we're working on accuracy at this point. We're using the LiDAR. We're starting to get really good results from the LiDAR in the lab. And this is an important lesson that the lab and the real world are very, very different. The robot doesn't crash or anything. That's no fun. But I know I teed it up for you're going to see something cool. Lies. Sorry. But in the lab, we get amazing results from the LiDAR. Amazing. And then you move out into this warehouse space. This is much more typical to what a job site would look like. And the LiDAR sucked because if you kind of look around, it's seeing 2 or 3 interesting points every 20 feet, which is just not enough to actually do most of your standard point cloud type localization algorithms on with any sort of accuracy. And the general accuracy of the sensors plus minus a centimeter. So we're trying to eke out as much as we can with the base at this point, and building in the autonomy steps to really run the robot autonomously, see how we're actually going to do path planning, motion planning, trajectory planning, and printing. So you can see it kind of doing some prints here. On the next slide, this is actually the first print we did on a real job site. This was a renovation project up in Boston with one of our customers. They let us come up and test up here a few times. It was actually a pretty warm day. It was 42, which is pretty nice. Beta 3, the coldest day we've dealt with was 9. And being on a job site for 10 hours when it's 9 degrees, pretty awful. So it's just, robot going around. So then, so we've learned a fair amount.
Did it work on the job site?
I mean, it created something. That was the goal. So yeah, it worked. It didn't print anything, it was not kind of accurate. We learned a lot from this, we're actually doing our control move totally wrong in this video, because it's supposed to ramp up, ramp down, and then we realized that the way we were feeding the our PID was just misconstructed, so it was actually just like doing the totally wrong thing, which is great. So, still learning, right? Still 4 of us, still figuring out. The hard part of robotics is glue. Building a system, sure, but you select all these components. How do I make all these components work well together? And this was kind of figuring that step out.
What do you guys use for your accurate positioning system? Is it just the LiDAR, or are you guys using anything else?
Don't jump ahead.
Oh, all right.
That's part of the whole story.
Ah.
At least they're setting up for something here.
Fair point.
So, beta 3, notice there's a 0.0 after this one. The goal of this initially was refine the package, build a couple so we can test and develop faster. Still 4 of us. This is a photo of my garage. The week before Houston shut down for COVID, we saw the writing on the wall, and we actually that day installed the motion capture system in my garage. You can see it up in the right corner there. And so these are 2 of the robots, Raphael and Michelangelo, kind of getting their finishing touches in my garage. So the main gist of this robot was mostly kind of mechanical bug fixing. So little things here and there to make the robot perform better. Battery management systems, we actually had a custom board made that handled the battery safely, managed battery state, and did kind of better, more low-level commanding to allow more access to the different features of the robot. But mostly adding safety. We added a remote e-stop, so we actually have a physical e-stop we can push that will shut off the robot, just no ifs, ands, or buts, so that the robot doesn't drive off the side of the building, because that would be the end of everything for our company. So we can't do that. So that's kind of what's the mechanical point of this. At this point, we're deep into the software. We're like expanding the print library. We're trying to figure out how to get the accuracy we need. I mentioned the LiDAR problem. We're still investigating that. Do we do a custom ICP algorithm, knowing certain properties about the structure that we're in? Do I do fiducial slam? We worked on that for a while. Optical flow using visual odometry, the Z cameras, or the Intel.
RealSense.
Not the RealSense, the other one. There's a RealSense and then there's the visual.
Oh, I know what you're
odometry one.
Yeah.
Do you know what that one's called?
I got it.
Not important.
Yeah.
We look at optical flow, looking down. We started developing that. So we're trying to figure out, okay, how are we going to eke out this accuracy that we know we need? So what we did was change, because we weren't getting what we needed to. And one day, I'm looking at this thinking, we've got to hit 16th to 8th inch accuracy. How do other people do it? Total stations are the industry standard for precision localization on job sites. You'll see them on the side of the road. You'll see them in commercial construction. It's the tripod fancy thing, and then the dude with the pole. Those are accurate to 16th to 8th inch all the time, and they're doing it with a single point time of flight laser on a gimbal setup. So we should probably localize ourselves with a single point laser with a gimbal and a time flight setup, because that seems to be the way the industry is doing it. We're not getting success, and so we need to do something that's going to work. So we developed this setup in a month and a half. We said, okay, let's try it. Like, we got to do something. Pivot. Let's figure this out. So kind of here are some of the videos of. Oh yeah, this is the one. Let's see if I can skip this is it moving around in my garage. So this was a month and a half after we decided we're going to do this. So I'm trying to turn this on. There we go. So this is adding those lasers. So it's a single point laser, actually using phase shift. You can ask me how phase shift works, and I'll tell you black magic, because I don't know. But it's accurate to plus minus a millimeter up to 500 meters away, which is pretty outstanding. The lasers themselves are $2,000 a piece, so there's that. So in a short order, we said, okay, let's get some of these lasers, let's try it out, let's build an infrastructure, let's just knock it out. So Kevin and I sat down and just code, got this working, and this was, this was it. Had we not had the courage to make that change, I wouldn't be talking here. Our company wouldn't exist. We would have failed. The path we were going down was not sustainable. We would not have gotten there with the technologies we were aiming for. So making this change and throwing away a lot of work is what led to success. And that's, you hear the pivot stories and stuff from startups. Like this was ours. We can look back at this and say, had we not done this, we would have failed. So take encouragement that sometimes you just got to throw it all away to do a better idea, and that's okay. Just have the courage to make that choice when it makes sense. And this is really what enabled us to start taking off. We built 3 of these robots. This is actually Beta 3 getting snowed on in Boston while it's printing. That was a delightful day. There's a few photos from job sites. So the one in the upper left here, like that's a nice looking job site. That's kind of what we actually deal with in the real world. The bottom left is kind of the gross case where there's just stuff everywhere. That's why automating construction is very hard, is because the job site changes every day. People are bringing in stuff, they're bringing in material, they're bringing in pallet jacks, they're bringing in, the man lifts, they got their tables moving around, a whole bunch of sheet metal gets dropped in the middle to get installed down the center, and that's changing day by day, hour by hour, and that's why construction is so hard to build automated solutions for, is because of those changes. And even simpler ones, you think, okay, but if you've got the base building, you're good. Structural steel could be 3 inches off. So it's okay, how do you model that? How do you handle that? We had an example recently where the core building was 5 inches longer than it was supposed to be, which meant everything on the left of the core was correct, and everything on the right of the core was 5 inches too close. So we had a whole big hoopla about that. And again, that's why construction is hard. That's why automated construction is hard, and why they don't. And that's part of the reason we're doing this, is because it's an early point in the construction site where, for the most part, all we have to deal with is the fact that the core isn't quite right, or the columns aren't quite right. We have less to deal with all of the people and stuff and movement every day. And then, as I said, kind of the beachhead for commercial construction automation is that now that we've figured this problem out, we're accepted on job sites, how do we move along? So anyway, back to kind of technology. So this robot lived for, what did I say, a couple months.
So, quick question. Before y'all put the robot, y'all have to clear the area of any materials,
So
including...
we work with the customer because you can't, the way they do it now, the area has to be clear for them to snap chalk lines. So we fit into the process as it exists today already, which is, again, part of the reason we chose this as the step. It's like the way they do it today lends itself well. So the way they do it today is they mark what's called building control, these known points on the floor, and that correlates to the model of,
Yeah, sorry.
that correlates to the cabinet. So they mark those ground truth points, and that's what we use too. And then they clear out an area, and then they measure and snap all their chalk lines, and then they kind of build in that area while the guy's doing the next cleared area. So we can fit into that same flow really well, and we have an open area with a known translation point from physical to digital already exists. So that's kind of why we do this. But yeah, I mean, at the end of the day, we do spend a lot of time sweeping. And if people, they're supposed to clean it out, but we're not going to be jerks about it. So I've spent a lot of time moving pallets of stuff around and sweeping. A lot of time sweeping, but
that was going to be my question.
Yeah. Oh yeah, I've spent a lot of time sweeping. We have a joke. Been meaning to get Derek, founder, CEO, name tag that says founder, CEO, and laborer. I need one too at this point because I go to job sites and mostly just sweep and let them do their thing.
I'll come sweep for you.
Yeah.
I'll come sweep for you.
There you go.
Why haven't you guys considered a sweep attachment for the robot at this point?
Because of the time.
Yeah.
The time to actually build that and the cost of doing it is high compared to the cost of somebody sweeping.
That's fair.
Alternatively, Roomba.
So job sites are far dirtier than I think you're giving them credit for.
It looks clear right there.
It does. That's because we swept it. So moving on, Beta 4. This is our current robot development. That's actually what's in the Pelican cases back there that we'll show you in a little bit. The main step here is this one. Let's create a robot that works. We now know that the lasers work. We also know that we need a pitch axis on the lasers. So that's what this is. It is a huge step up in sensing in the gimbal. So it's a pan-tilt gimbal unit with sensing accuracy to the 30 arc second range. So very, very accurate sensors. And you're thinking, oh, Logan, you're on a flat concrete floor. Why do you need pitch? Because one, the floors aren't actually flat. And what is really flat, man, right? What is zero? What is zero is a huge problem. And anytime if you ever get into like precision robotics in any way, zero is a really, really hard problem. Because I might say like, this is the 0 point of my arm. And you're like, okay, but like, is it this or that? You're like, well, it might matter or it might not. And if it does matter, how much does it matter? And if it matters to 1 arc second, you're going to spend 6 months figuring out how to actually measure it to 1 arc second and figuring out how do I design a fixture to hold it, to zero it to 1 arc second is an incredibly hard problem. So if you ever get into precision robotics, zero is super hard. Time is also kind of a made-up construct that really messes with you. If you have multiple computers in a system, time sucks. So just be aware.
So that one Rick and Morty episode, that one clip from Rick and Morty of True Level.
Yeah, pretty much, right? So Beta 4, back to this. This robot was developed a little bit longer. Again, solving kind of the more precision problems, putting the finishing touches on it, and putting the pieces that we needed to be able to sell this as a service. So we do this as a service, but overcoming that technology hurdle to get to the point where I can go to a customer and say, hey, I can do your layout for you for this much money, and like be confident and just say that, and then no caveats, no, oh well, if this, and we're going to, it's like get rid of all of those and just say, I'm going to do your layout for you. It's going to be 1/8 inch accurate. It's going to take me this long. When do I start? And that was one of the key technology hurdles, is to get to that point. So the goal was this robot getting us to that point and building a decent number of them. So we've built 10 of these now. The key thing, like I said, the pan tilt unit, that was on pitch. As the floor rolls, you can get a 1/4 inch difference in the floor roll, which doesn't, if I'm looking at something 3 feet away, 1/4 inch roll, not a big deal. If I'm looking at something 30 meters away, 90 feet away, a 1/4 inch of roll, a 1/2 degree, is a lot. And so you need to be able to account for that and calculate. So that was kind of the big change with this from an accuracy standpoint, a code standpoint, and secondarily you'll notice that there aren't a bunch of gross wires and grossness. We basically took all of the PCBs out of the gross housings on the previous robot and just packaged them into our own. We told the vendor we were doing that after we did it. It was fun to send them a photo and be like, hey, look at all this. Now we actually we're implementing today, they're testing hopefully for the first time, a board that replaces the entire 2 boards that are yay big and yay tall with a single board that's this big that just does what we care about. We can produce for $100 instead of buying their system for $7,000. So kind of the steps we're starting to take now is those types of optimizations. But this platform enabled us to sell to customers. We are at that point now, and it's pretty exciting. We have, really this robot came to life with 4 and then eventually 7 engineers. We have 24 people now and still growing, so the team has kind of exploded. Some other cool stuff we're working on, just because I think you guys will find it interesting. We have, I think this is a video, we're adding cameras to the, there we go, adding cameras to the robot, to the lasers. So right now it finds these targets, it actually uses the reflectivity of the target. That target's on building control, I know its diameter. I sweep that target to know where that target is because it's a circle, so I can calculate the center. But we have to do that from a fixed position, and we can't close the loop while we're driving, because if I close the loop using the lasers to the base is telling the lasers where to point, you get a lovely feedback and the whole thing freaks the hell out. So we're actually adding cameras to the lasers to close the loop directly. It'll cut down on computation time, so the robot will stop, measure, print, stop, measure, print. The stop time is about 20 to 30 seconds, and we spend about 60% of the entire time on site stopped measuring. So if we can cut that down from 20 seconds to 5 seconds, we can literally print twice as much a day. So it's a huge win in production. So that's kind of just an interesting, fun thing, using like IR and reflectivity and kind of classic CV techniques. So some cool stuff there. Sweet new tablet interface to kind of enable. Our goal is lowest common denominator operator. We want to hire, Joe Schmo off the street, a smart 8th grader, to go run the robots, because a smart 8th grader is a lot cheaper than any of you guys. and enable a different class, a different group of folks to be able to run our system. And so that means the system needs to be intuitive, easy to use, stable, reliable, easy to set up, easy to move around. So starting to move towards that. And so that leads to the next platform, Mark 1. We built a sweet hardware team, some of the most talented people I've ever worked with, all in one room, which is pretty hot, to build a robot that is more deployable, that is more reliable by design, more manufacturable. Our goal is 1 robot a week per person. So 2 robots getting built simultaneously at a rate, ideally at the end of the year, of 2 robots a week. You can see the one picture on the top, that is to scale. So Mark 1 is 60% of the size of Beta 4, fits in one single box, liftable by one single person, a huge usability win. And then you can see kind of some of the details. You know, this is a legit robot down on the inside. Some really cool features, some really good robustness by design, reliability by design, calibration. You know, how do I build a robot in a week is a really hard problem to solve. So like those are the types of things we're trying to solve now, because eventually, because we're providing the robot as a service, you know, one robot can service 3 customers in a week. So we don't need 100,000 robots to be immensely profitable. We need, you know, at full scale, 2,000 or 3,000 robots. But, you know, these are very high precision machines. And how do I build a high precision machine and have confidence to send it out the door in a week? You know, that's all of the assembly time, that's setting 0 on the actuators, because again, remember, 0 is really hard. So clever ways of being able to set 0 all at once. So those are kind of some of the interesting problems we're trying to solve with this robot here. And it also has that clean perspective that, you know, this looks like a commercial product. It looks like something if you walked out to the job site, you know, you'd see, be like, oh yeah, that's a group of professionals there using that thing, versus, you know, somebody from a lab, which our old robots definitely look like more like lab robots, prototype robots, versus this is, you know, you trust this implicitly because of the way it looks. And also our competitors are kind of 6 to 12 months ahead of us, and they have cleaner, more well-refined products. So our first really big splash in the market needs to be at the same standard that they've set, so that they look at our robot and our competitors' robots and say, yes, any of those 3 should work. What's the difference and why should I pay for one or the other? Rather than looking at ours and be like, well, that one looks like shit, so I'm going to go with the one that doesn't. You know, because people are fickle like that. So this is what we're doing today. This robot's going to roll for the first time in December on job sites in January. Our current expectation of build for next year is somewhere between 40 and 60 is our goal for robots out into the world, kind of flooding the market and building scale. So that's really where we are today. We have, you know, something that works.
All right, we're down here on 24.
I'm going to get rid of Paul's narration.
2 volt.
But this is a, oh gosh, quit it. What? Sorry.
Oh no.
There we go. So here's an actual video of what we print on the ground. This is, you know, drywall track. You can see 2 parallel walls there, so that's a fire-rated wall. And then they put 2 layers of board on one side, 1 layer on the other. The triangles are the electrical outlets. This is a very odd building. The entire exterior was curved, so it was a nightmare for them to lay out because every wall was at a slightly different angle, but the robot doesn't care because 0 and 1.287 are the same to a computer. You can see, you know, the dotted lines would be ceiling features in this case, and you can see it lining up where it's supposed to be over there. So at this point, the technology is doing what we're supposed to, and like I said, we're transitioning into kind of some of the scale and solving those problems. You know, the robot needs to get better, but we have a robot that works. It's now, how do I build a lot of them, and how do I sell a lot of them? And that's actually, you know, George has
Thank you.
how we do that.
So that was a very thorough recap of like the origin story. Yeah, awesome job. Now I'll move over here. I tend to wander and move around too, so sorry in advance to the webcam. But Logan walked you through the origin story, a lot of the trials and tribulations of getting a very technical, very precise product, a piece of hardware, to work. And the next challenge is, okay, it works. How do we turn this into a business? And that's where I come in. I was brought on, as I mentioned, recently because we were only recently able to prove that this is a commercially viable solution that solves a pretty significant problem very, very well and is valuable to customers. So, it's a whole new set of problems to solve. And now that we've got, there's optimization, there's improvements, and there's continuous iteration. That's, the nature of being in any business. But the primary objectives that we have now are how do we scale to full commercialization. And that's where branding, marketing, and sales come into play. That's my role at Rugged, is figuring out how to communicate Logan and Derek's vision out to the world, how to market that, how do we target customers, people that are going to pay for this, how do we demonstrate that value proposition out there so that this is an attractive option to status quo. In any sort of product that you're out there selling, the status quo is like what is the best alternative, and a lot of times the best alternative is like not changing anything. Like the construction can continue to operate using these same methods that Logan iterated on that were developed by the ancient Egyptians. That's still happening, on just about every job site today. Why do I need to change that if it kind of works? So that's our challenge, is demonstrating like, yeah, this is kind of wild, but check it out. It's faster. It's, this is precise. It's faster, and it provides a lot more detail, and it coordinates all of that effort that is sort of dislocated among the different trades that are doing this individually. And then on the sales side, I mean, there's really three things to sales. It's generating revenue, delivering like a lights out badass customer experience so that the existing customers that you have done a job for are, repeat customers. And then accelerating growth, and that's what we touched on, some of the optimization, doing different practices, both on the hardware side, on like our operation side, how we execute things that are repeatable, things that will enable us to do what we do faster, better, cheaper. So that's where, Logan touched on some of the software iterations that we're doing with our iPad. Effectively, our iPad today behaves as like a remote control for the robot. But we've recognized that this is also a way for us to communicate out to the different stakeholders on job sites, like what we're doing. So there's tremendous advancements that we can make within that platform to show progress on the job site. Like if we need to make changes on the fly, if we need to communicate information back to from the field back to the office, those sorts of optimization. So really that's it. I don't think that's nearly as interesting as the origin story and talking about how we built this platform. But just wanted to mention that because that's why I'm here. So any questions about that aspect of the business?
So what do you think that is from your perspective, is the primary way you can get this out into more people's hands? What's the primary thing that you want to, like, the strategy that you want to have to go out to this field market?
I think that we chose, that's a great question. I think that we chose a great business model. What Logan mentioned is that we behave as a subcontractor on a job. Hey, Mr. General Contractor, you have all of this activity going on. You need to translate this model into this physical product and get your client moved into the building as fast as possible, and we can help deliver on that. And there are other solutions out there that either lease the robot as a service or sell the robot outright. And the reason why we chose this particular business model is so that we can continue to learn and continue to iterate and to kind of take that responsibility off of these existing stakeholders. So Logan mentioned our vision, and I want to kind of double click on that. Layout is the first problem that we can solve. This is our first product. This is our first commercially viable product. And it's an important one, but it's not the only one. I think that once you solve the problem of precise localization on a dynamic construction environment, there are all kinds of ramifications and iterations that you can take that. So the first one is this layout, right? That's cool. We've got a robot that can print the floor plans on the floor. If we're telling you precisely where to drill a hole, like, why don't we just drill the hole? So, you know, there are several iterations of this and several pieces of technology available today that wouldn't be terribly difficult. It wouldn't be a huge leap for us to start augmenting what we already do and start, you know, instead of providing instructions and precise, you know, direction for how things get assembled in the field, to actually take on some of those things and start actually assembling things in the field and introducing automation into the construction environment. There's also ramifications like upstream of like how design information gets communicated out into the field, and how can we create maybe a platform that can help other applications of automation on dynamic environments, not just construction. So to answer your question, I think that's kind of a circuitous way of answering your question, but like the best way for us to get this out into the world is how we're taking it on, and providing this as an end-to-end service, again, so that we can see how this works, we can learn from how it works, we can improve on how it works, and we can be thinking about that next product that we're going to deliver out there.
Who's your targeted customer? Companies or?
Yeah, so target customers right now, we've had all of our success with commercial general contractors. Commercial meaning high-rise buildings, hospitals, and the reason why we choose that is because there's a level of precision required in the commercial world that isn't quite there in residential. Also, concrete floors, you know, that's something that we're optimized to print on. We haven't quite figured out. I think printing on wood floors and then like in, you know, residential construction, it's just not the same level of detail and not the same level of precision. Often, if the layout doesn't work, they can take a hammer and, you know, bang a board, you know, to make it work. And we're dealing with, you know, steel, concrete, and very and glass, and like very precise lines. The other thing I'll mention is we're recently getting a lot of attention in the tilt-up market. Tilt-up construction is where they pour a gigantic slab, and then they start pouring each wall panel, and I'm talking like 20 feet wide by 30 to 40 feet tall, concrete panels that they will then hoist up with a crane. And you see this in industrial buildings and stuff like that. And really interesting opportunity for our robots to perform there, because there's actually a substantial amount of layout that goes on to create the formwork where concrete gets poured. You have to be very precise about where the structural anchor points are and the bracing is before you pour the concrete, so that when it ultimately gets pulled up by the crane, it doesn't crack because it's been positioned in the incorrect place and you have incorrect load balances on different points. So our target audience is large general contractors, concrete guys that do tilt up, and then some of the key trades like drywall is the one that Logan mentioned. Drywall is sort of the leader and does all of the heavy lifting on construction sites, because they lay out where their walls and doors are going to go, and then all the other trades kind of build off of that, and they're like, oh, okay, well, if that's where the wall goes, then I need to put my, you know, duct on this side of the wall, not this side of the wall, or I have to make sure that the you know, electrical piping goes this way, then down this way, and I have to put my box here. And so anyway, those key trades that do a lot of layout are also our target audience. But what's really interesting is like this involves an education almost. You have to educate not only the customer, but people that are stakeholders in this whole process. The design community, like architects and engineers, are super excited about this, because this basically iterates on the designs that they put out into the world. So they design things in theory, they hand it off to the construction teams to actually build, and we kind of fit right there in the middle to help translate that conceptual idea into a physical reality. So although architects and engineers don't buy our solution, they are definitely advocates and people that we, you know, want to talk to.
I was going to ask what he asked.
Oh, okay. For me, I guess my question is like, what kind of hesitation do you get from customers, either than like education? Because I can kind of, from what you guys have explained to me, I'm sold. Like I would totally hire you guys. But kind of what kind of hesitation do you guys face from them other than education, right? Because when you say, hey, we've got a robot that can automate this, I understand
That's a great question. So one of the things that we are finding is that at the top levels of organizations, at the C-suite and at the executive level, they see the value and they are sold, right? Once you kind of get down into the project level, and this is really interesting sort of dynamic in the construction world. As you start getting down into the project level, there's this conservative sort of reluctance to adopt something as wildly crazy as putting a robot on a job site. You know, I mean, like that concept is like, that's cool, but who's done this before? Has this been proven? And so you actually have to, like, you know, we have had to significantly discount just to get the attention of some of our, you know, of our early customers to prove this out. Say like, look, let us do this much of it for free. Let's demonstrate how fast we're going. And I promise you, by the end of this thing, you're gonna want to do this full scale on all your projects. So we're in that at that inflection point right now, and so we're seeing that excitement. We're converting that excitement into signed contracts and dollars, and that's the fun part of my journey here so far.
And it's kind of weird too, because the projects each act almost like their own business inside of the larger business. And the way the project manager is incentivized is how much profit does he make on the project for the company. If he hits that goal, he gets all of his bonus. So he sees this as, I'm already paying for layout, why would I pay for it again and cut into my profit and hurt my bonus? He doesn't say that out loud, but it's like a lot of the way they're incentivized. You have to convince them that it's good for them as much as it's good for the project, because that's the way human beings work. Any incentive program, people will play the game as it's designed, and we have to know how their game is designed to be able to sell into that.
100%, yeah. And even though you can make the argument like this will save you a tremendous amount of time, both in the activity of doing the layout, but also in having that precision and detail of a fully coordinated layout on the floor, very specific instructions for all the trades to do their work faster. That's something that they kind of get conceptually, and that's the value proposition that we underscore and deliver on. But to Logan's point, if I've already paid for it, this is maybe an additional cost, and yes, you are going to save me all of this time, and that translates into dollars, but I could either take roll the dice and try this thing, or not try it and have the guarantee, like I know I'm going to get this much money by not spending it on this thing, versus like I could spend a little bit of this money and potentially save more, and it's a gamble. You know, there are a lot of people that are risk averse and aren't ready to do it yet.
In the legal sense, have y'all had any problem?
That's a great question too.
Yeah,
totally new product. So the talking point that we hit on, and the thing that we write in our proposals, is that this is an interesting thing. Like, construction is a game of risk mitigation, and there are certain activities that that the trades historically have had to do that aren't part of their core business. And I'll give you two examples. One is drilling holes into a slab, right? So there are concrete guys that pour the concrete, and then there are plumbers, electricians, people, pipe fitters and things like that have to come in and put their pipes in place. There's often times where they've got to do what's called a riser, where they have to drill a hole into the slab to fit their pipe down so that it goes to the to the main and all that sort of stuff. And often, since it's their pipe, they're like, well, I have to drill this hole. And so they had that in their scope to do. And after a certain amount of years, they recognize like that's a lot of risk we're taking on drilling into a slab. I don't know if you guys are familiar with post-tension slabs, but that's a concept where they have tension cables embedded in the concrete, so that when the concrete dries, they're able to ratchet those tension cables and effectively compress the concrete to make it stiffer and stronger. Well, what happens if you drill a hole in concrete and you hit one of those tension cables and it pops? you immediately lose the structural integrity of that slab. And it happens all the time. So plumbers have gotten to the point where they're like, look, I'm just, laying the pipes. I'm not going to drill that hole. And the guys that are best equipped to handle that risk are the ones that usually take that on. The other is fire stopping. So anytime you penetrate a fire-rated wall or surface, you have to use a very specific method in ensuring that there's a seal around that penetration. So if a pipe goes through a fire-rated wall, there's a very precise method about how you correct that penetration and seal it with a specific fire-rated caulk and maintain the rating of that wall. And that's not part of plumbers that just fit pipes. They're not like the experts at maintaining fire-rated walls. So they've outsourced that activity to the people that are best equipped to handle that risk. So those are just like two examples of like specific problems that happen in the construction world where the people best equipped to take on that risk actually take that on. And layout is one of those things that we feel like we are best equipped to take that risk on. This is something that math and lasers and like automation can do a lot better than guys crawling on their hands and knees trying to remember and add up dimensions and fractions in their head or write it down on a pad and then hold this part of the chalk line and let's pop it here. I mean we can do this more precisely and fast, and we're happy to take on that risk.
Dr. Ballerini here is in charge of civil engineering. He also teaches a class on concrete and stress analysis. So if anyone here is in civil engineering, take that course. So if you're mechanical, you can also take the course. Yeah.
Other questions?
All right, everyone please give a round of applause to those presenters. Thank you all both so much for coming out here.
Yeah, I appreciate it. So we're going to put our robot together, drive around
together already. So.
Okay.
Sorry for
Yes.
Yes,
Not at all.
Quick plug. We do have job recs open for interns, co-ops for spring and interns for summer, and full-time either robotic operations engineers or software engineers for kind of graduation either in December or May. So if you fit any of those categories and are interested, come talk to me or feel free to apply online. Just the plug.
We did ask someone to bring their resumes, but I don't think anyone actually brought one.
That's fine. I mean, if you hand me your resume and be like, thanks, and I put it in my backpack and I forget about it, I should apply online because that's where I actually see all the stuff come through.
At least you're honest.
I got a lot of things to do, not a lot of time to do it. Alright, I'm going to put together the robot. And then
All right, everyone want to stand up, and you can leave your bags in here, but you can go watch and build the robot as I slowly
Logan,
document.
this is your laptop.
yeah, my laptop.
Someone help me grab the webcams.
I got you.
Yeah. Put that one in. Wow.
Yeah, I'm fine.
Yeah. So UH parking showed up. we got it though. We paid it. So yeah, we're good. We got it. It's stupid. Yeah. Yeah. Well, yeah, because it's moving.
Right.
Yeah, it's losing all of its resolution right now as we slowly move out to the demo.
Are you
set.
recording it?
Yeah, it's on
Discord?
It's on YouTube.
It's on YouTube.
Yeah, it's on YouTube.
Not on Discord.
It's on both.
Okay. Somebody told me, hey, what happened to the Discord thing? And I'm like,
It's on YouTube. You put the link up. Okay.
So does it actually require that many batteries to power?
We need 4 to have enough power, and then they use so it's not too long, so I can continue on. Can you actually keep it in or? Yeah, it can do it. George, could you pull these on?
So it's running 4 dual batteries, 20 volts. So it's running basically a 12S system.
2S, 2P.
2S, 2P. Right.
It is literally the DeWalt. We did this on purpose so that I don't know if you know this, but if you travel with lithium-ion batteries, you're limited to the amount that you can carry. Sometimes they don't make it in transit. What happens if a battery goes bad on a job site? Well, we can say, hey, dude, with the cordless drill, give them your thing, and we can put it in there. Or we can run to Home Depot and go buy some new ones. They're actually great batteries. They're robust. They work. They're proven. Guys use them on the job site, and it makes it real easy to swap them out and troubleshoot and all that other stuff.
Are you guys thinking of doing compatibility packs? So if you guys have like Ryobi or Makita batteries, you can switch out, or you just stick to the wall.
Those are preventative. You don't need anything
Kickability.
big. Like,
What's the resolution so
Our one is designed, some of the specific requirements for the next robots are
Steel-toe boot.
kickability, droppability, like it must be able to be dropped, must be able to be kicked, have wrenches fall on it, like that is part of the requirements. So we run like test cases of if I had picked it up and just dropped it on the corner, would it survive? Because this is job sites, that is going 100% going to happen at some point.
Has anything fell on it?
Oh yeah.
Yeah.
I mean, this one actually does a pretty good job, considering it wasn't actually designed for, like it was designed with that in mind. But like I said, these robots have been snowed on, they've been in 9-degree days, they've been in 105-degree days.
You guys should put some remove before flight tag on this to make sure you don't forget.
It's really rad. Also, the robot's smart enough, if it tries to move and it can, it's gonna go, hey, I can't move. It won't hurt anything.
What computer are you guys using on
There's
board?
actually 2 computers inside. There's a Latte Panda Alpha, which I actually hate and don't recommend, but we're deep in on this robot, and an Intel Nook. So the Latte Panda is actually the less powerful computer, but it is also, but it runs well enough. It's the thing that makes decisions. It holds time, and it makes the design, like the decisions about how to move. And the Nook does a lot of the high power computations, vision processing, etc., and then crunches that down into small bits of data to send to the second computer that actually makes the decisions. Per Teenage Mutant Ninja Turtles, the controlling computer is Splinter, and the reporting computer is April.
It's interesting how you have a physical stop switch.
Yes, that is, right now the safety system is exclusively humans, so this could drive off something or into something if it makes a mistake. Part of the next robot will actually have a virtual bumper, so it won't drive off of something or into something. It's an important kind of upgrade to the system, but right now the human is still the e-stop, and even on the new system, the human will always have the kill button, because it's, you just gotta have it. Half
40
meter per second.
No, you can't ride it.
So how are you guys dealing with the GPU and CPU shortage?
It's not too bad. The new robot's actually using NX, Xavier NX, and we've purchased $50,000 worth of Xaviers, so we're good for a while. Yeah, so this is, I haven't obviously connected the cables to the printer. What are you doing?
And that's why we
And that's why you have these stuff. Oh, this is the one that I have to, there's a screw. I'm supposed to put down.
the emergency stop work? Is it just like cut power?
Yes.
Cut power.
Georgia Nancy.
Yeah. Yeah, it cuts. It just shuts it completely.
But it is a wireless kill switch, right?
That's right.
So if there's any issue with transmission,
So it's a physical relay it hits?
Yes.
Oh. Let me actually make sure it's pointing at the robot so you can see.
This connector is a little finicky, so there's a screw right here that you have to put in to get that connector. So the way, you'll didn't see us come out of the box, but obviously it's the 2 boxes that we brought with us. This and this, the printer assembly and the gimbal assembly, live in 1 box. The robot lives in the 2nd box. We have to actually build it on site, which is a giant pain in the ass, which is the important part for running a new robot, is all together, all in one. The disassembly assembly leads to potential calibration issues, leads to issues like this with the line mates, and anything you have to take on and off is going to be a problem. But we just weren't able to optimize for those things with this machine. But the new one is good.
What I'm doing is some of this is like this is field. This is doing it.
Yep, yeah, most of it is 3D printed plastic. Again, it's speed. We have a whole bunch of printers and stuff.
It's only takes us.
And now we have a whole suite of set. PLA. Almost all of it, right? Standard PLA. So anything that is structural, there's a few structural pieces that are metal, like down inside the wheel modules and stuff. There's some metal things hidden in there for like drive shafts and main like load bearing components. And there are a few structural plastic pieces, but they're structural plastic pieces, not structural plastic pieces. Like this corner is plastic on most of the robots, but it's also a huge cross section. We can print 80% density, so it's really strong. We don't have to worry about creep that much. And then all of our precision components, like all of this is in here, is all metal. You know, there's a few plastic guards, but for the most part, the money maker on top is only metal 5% equipment. It's using Zetlex encoders, which are these really neat magnetic encoders using magnetic like field differential to determine position, and they're like 30 arcsecond accurate in position sensor position measurement. So that complements our plus minus 1 millimeter laser pretty well, and that's really how we get that 1/8 inch or better positioning. So the way while I wait for it to come back out, the way we actually position, I didn't describe this well in my presentation. As I mentioned, we have the building control points. I have this known point in space of where this corresponds to this in the model in the real world. So what we do is we put a target, we call targets, literally a 2-foot PVC cylinder wrapped in orange shape, orange shiny shape. That's it. On a fancy tripod that we can level with a laser projector, so we can like make sure we're right on top of that point. I tell the robot, hey, your target's at this location and that location. And then the laser finds that target. Like once it finds the target the first time, it knows where the robot is from then on. And literally will sweep left, right, left, center, collecting data and doing a best fit of that circle onto that full data set to determine where the center of that target is. Now I know where that target is with respect to my gimbal and chain. I know where the target over there is with respect to my gimbal and chain. Now, where am I, the robot, do that calculation, do any correction necessary, move on. The way that actually, so we're waiting for the router to come back out. It's being a little fickle.
Where did the aha moment come from for the lasers? Because I have a friend who does land surveying, but I never would have thought like, oh, okay, yeah, that's a great idea. Let's add that to my robot.
So some trades, the most sophisticated trades on site will use total stations, or what they're called, to do that layout. Like that is the industry standard of this is the best you're going to get. So it's like, okay, this is what most precise people who care about precision are using. So that was kind of like, we've seen it on site, we talked to like vendors and stuff. And that's, again, industry standard for what? For high localization, precision.
The benefit to what Logan is describing with the targets laid on control points and them being just literally PVC pipes with reflective tape is that the localization and computation is all on board. So there are other autonomous precision pieces of hardware out there that require a total station to kind of dictate and to tell where, drive this thing where to go. And I guess the drawback to that is that you have to always be supervising this thing with the total station precisely positioned, and you always have that line of sight. So if, for example, we're doing construction in this area and we have to, do things over there or over there, we have to potentially reposition that total station once or twice. And your friend that's a land surveying person will appreciate this because you have to get trained up pretty heavily to use those things. I think a lot of those people are provincial, expensive, and our goal is to have a fully autonomous thing where we can set up targets and walk away, and potentially train someone on site to say, hey, your control points have been already laid out. Place the targets on the control points, and we can print 100% autonomously without having to supervise this thing with the total station and reposition it and maintain alongside it.
Okay. So eventually the most human interaction you want this thing to get is where exactly am I supposed to go? And then you just let it go.
Yeah, the human interaction is hopefully just take it out of the box and place targets. Hopefully that, and then push the button. It's like
When it's supervised, the button has to be carried by the supervisor.
correct.
Kill switch. And as soon as the button moves out of range, it kills the.
No.
Is that
Well, it does.
If you move out
Unfortunately,
of
the range is really, really far.
Yeah.
Derek once took it to the bathroom with him, and it wasn't until he went into the porta john 3 floors down and across the building that it actually cut out. And then I had to sit there and wait for him to come back to the bathroom. You guys' network stuff going on around here is futzing with the stuff.
Sorry.
Doesn't one of the professors have a spare radio jammer sitting around or something?
Dr. Wong is not here right now. I made sure of that.
Okay.
So what the robot actually does, it's a self-contained platform, and all of the brains are on the robot. So it projects its own Wi-Fi signal. It connects it to LTE itself. So I can pull the plans from the internet down to the robot from wherever I'm at. Job sites, we have yet to be on a job site without LTE, but they do exist, so we have a backup route through the tablet. But the tablet has no smarts. It purely connects to the robot's network and just shows me robot status. I can send off individual commands from the tablet. But in this very network interesting environment, it's having a hard time. Fortunately, we don't have to worry about that because job sites have 0 networks. We are the only one, and it makes it really easy.
So is the kill switch, is that like a dead man switch style where it's constantly sending an interrogator signal and then if it doesn't the robot's constantly sending an interrogator signal and if it doesn't receive a signal back, it kills the bot?
Yes.
Okay.
It has to be built that way, right?
Huh?
It has to be built that way, otherwise you'll not be able to kill it.
Correct. Yeah. So it's the way the robot can stop. You have the e-stop, obviously. When it gets out of range or when I push it, that'll die. There's the physical button on the robot. So if I'm next to the robot and don't have a switch, I can push it. So anybody can smash the button and be like, oh shit.
Where is that?
Over here on the left.
Okay.
The e-stop. And the robot itself can issue an e-stop to itself to shut off its motors. So anything that can move, motors and the printer, are all on that circuit. So it will cut that circuit. You literally have no power to command anything that can move, but all of your logic stays up. And the way the battery management system is designed is that is a circuit. There is no logic associated with the e-stop circuit. It is purely electronics. If there is no signal, it will not go. It closes that relay. Okay, I'm reconnected. We'll see what happens. See if it stays connected or if it puts us up again. So we have the tablet. It is a very engineering designed tablet for engineers to be used by engineers, which is the reason we're designing a new one. Come on.
So you guys have Android application development or iOS development?
Android. Yeah, I'm just dropping in and out of that. I don't know.
Well, it's not the Windows tablet.
No, it's not the Windows tablet. Yeah, Android development, because we control every piece, the tablet, the robot, the applications, etc. So we use the AA tablet and that's it. So we can design for a very specific tablet, a very specific system because we provide everything. We don't have to put it on the App Store. We just make it for where it needs to be.
Would you guys consider using a tough book instead?
We have, but I'd rather honestly spend $150 on a tablet, and then if they drop it and break it, I can go to the store and get a new one. Then $2,500 on a tough book.
Military grade rugged laptops.
But they're 8 pounds of a giant pain. Whereas this is just I can smash this and buy a new one tomorrow. The number of tablets that will get smashed will probably be less expensive than a tough book.
Yeah.
It's also some of it is perception of just how easy it is to use.
Yeah.
Anyway, the Wi-Fi networks are stopping me from actually running the robots.
So I'm on Photonic Slab 10. It's bad.
We are should be Raphael Field.
I took a trip that last week.
Oh, yeah.
Something I like to do is
Probably, yeah. Really just drives around funny, that's all.
Yeah.
Pointing and grunting is almost as interesting.
I think I probably already
You know, people ask like, oh, can you do like a printing demo? I was like, well, I mean, I could, but it'd bore everybody to tears. Like watching the robot actually do its job is very, very boring. It's almost literally like watching paint dry, but it's doing something actually practical, useful, and monetarily valuable, so I don't care.
I'm surprised you guys have like a smiley face that has to you just have.
It's just not worth it. Like it's like, I mean, I could do that, but all that shows you is like, yeah, the printer works. But actually, like printing a whole layout, it takes time. People are like, oh, it's so slow. Like, well, it's still 2.5 times as fast as people because it doesn't think. It just goes. It goes slowly, but it goes.
I noticed there's 2 extra slots for the battery packs. Are those for extras or?
So that is so we can hot swap. So I can maintain power state to the system and not have to shut it down and do anything. So I can just come up with 2 new batteries, boop, pull these, and keep operating. So continual operation.
So what's the absolute minimum? What's the absolute minimum number of batteries that I can have?
4. If we put 2 on, it will overdraw the batteries and brown out the computers. So that's why 4.
What was the reason we're going with caster wheels other than like a lot of the mechanical wheels that we see today?
So this robot can drive 9-ish feet within a 1/4-inch accuracy because of the level of control we have with that base. So we get a ton of control and precision in the base motion itself. So we can actually close, if I don't have my precise global localization coming in, I can still close that loop with just the base in a relative position for a fairly long time. If we did one of those sets of wheels, then you basically can't trust that for the accuracy we're going for at all.
How do you guys deal with irregular terrain? So like if you have someone has a console on their skill, you have to just print out samples.
If it's small enough, we just pop right over it. If it's big enough, yeah.
I think once you edge around an inch, that's where the doesn't look good.
So it really depends on the terrain. If your terrain's like then you don't have to play 3 at a time. So just like some traction, then
yeah, we can try that.
That might fix it. Unless all 4 are simultaneously, in which case you're like
7-inch pounds.
Usually 2 of the robots. Sometimes we bring 2 robots on site just to demo our production time, and then bring a 3rd. Also to help with carrying these things. See, it takes both of us to carry one robot.
That's the big reason for our one. It's 60% size, carry a lot on person, deliver a lot of person.
So you said you right under?
Yeah, someone in the basement's running some tests. Yep. Sorry, live stream. I'm on the way. I'm on the way. Yeah, live stream's kind of sucky.
Basically, some sensors pointed down. Okay, so I can see it. But I'm just going to restart. Combination of sensors pointing down and sensors pointing out, so that we can characterize. If I don't see the ground and I should, like really the number 1, 2, and 3 risk is driving off the side of a building. If the robot, that's a couple failures deep, but it's a catastrophic failure and a very lethal failure, right? This thing falling even 1 story on top of somebody could kill it. So like that, we have to protect against that. It involves the robot not properly knowing the shape of the building. It involves a tow board not being installed that was supposed to be installed, and the operator not paying attention. So it is multiple failures deep, but it is still something we want to protect against. So that's the main virtual bumper reason from a safety perspective. The kind of third one that we've identified as being the most common hazard is I'm working on a ladder, And the ladder is not modeled in the building model, obviously, so the robot doesn't know it's there. And if the operator's not paying attention, you've got a guy up on a ladder doing some stuff, and having this thing bump into the ladder probably wouldn't knock the ladder over, but could cause a pretty bad fall. So that's ladders and edges are the two biggest things we like have to be able to protect against.
So you thinking of using optical like localization, trying to figure out if anything's new? You guys just going to put ultrasonic sensors or just pulse
Ultrasonics, just a buffer of ultrasonics, and it gets tricky because, as I mentioned, with that the stone, and if I wanted to lay out that wood panel, I have to get right up next to the stone. So it's more complicated than just, oh, there's a thing I need to stop. There's a thing where I don't expect it, and actually having to rectify all that information makes that challenge a lot harder and more interesting.
Intro to Sensors here used to have a class where they just had 20 ultrasonic sensors. You just had to interface with all of them and run tests on it. So let me see if I've got my old code from that. Right?
Yeah.
So do you guys not have the bot tethered to anything during the actual operation?
Correct. I haven't tethered one of these robots in years. It's awesome.
Do you think you're going to add that as a feature in the future? No.
I don't mean like cable tether or anything. I just mean like actually attaching like a bungee cord to like the top of the building in case it drives off.
No, like setting that up logistically would be pretty much impossible.
It's just bungee cord, right? No, it's like
George,
that's true.
Do you have the joystick from Trump?
It could be a pretty. I mean, it's a bungee cord, right? It's stretched. So,
But like right, but then the
there we go.
and then it messes up like that.
yeah, because it feels the tension.
Is it just a white light, or do we have the lucky of RGB?
No, just the white light. Okay, so we have connection. I'm going to get the actual joystick, which is our backup option if the tablet has some problem. So we can still drive it around for you with that without Wi-Fi to the tablet, which would be great. Again, nice, fully self-contained robot. That's one of the benefits. But before I lose that as I drive around.
Is it a PlayStation controller?
Yes, it is. Well, it's an off-brand PlayStation controller.
Ah.
AKA the little brother controller.
Ah.
Lasers. Just for funsies.
Just turn it off. What is it?
So you guys can see, I've got my laser here. I've got distance coming out.
Are those lasers that are actually used to tell the distance, or is it?
The lasers are actually visual. The way the magic of phase shift works is it doesn't actually need it, so it's purely an indication of what. So this is the gimbal's moving. It's choppy now just because of the way the commands come through, but obviously it commands more smoothly. So now we don't care about that, and we can use this to drive it. So as I mentioned before, holonomic. Really, what that means is not because it's cool, but because it was actually made sense and was useful for the application. You'll also notice it ramps up and this goes. And this is going to be the executive office. This is the snack room. I'm going to move this wall over so it looks really nice for the executive office. That's not the way it's modeled, but with the way that column lined up, that's what I'm going to do. Let them use their brain for that little bit to do those finishing touches. Let the robot do the bulk work.
So it's electric drive, but you've got a pneumatic system. Is that for the inkjet?
Yeah, so it's not pictured. There's a line that goes here, so a pump goes into here, pressurizes this, gets air pressure into there that forces the ink up through. Ink tube goes to here, and then these two cables go to there for actually commanding the print head. I didn't connect all that because I'm not going to print. There's a lot of unnecessary work. So that's the way that you saw it in the photos of those cables going around. The new robot will be no cable showing at all. The way you'll actually change the ink is you'll pop a cover off, you'll pull the ink canister, and it's a single point QD. So you just stick it in and twist, and then close the panel. The batteries will actually be hidden underneath the cover. Push a button, the battery panel literally pops up on gas shocks, all cool, fancy like, maybe with some smoke coming out, and then you swap the batteries that way.
I hope there's not any smoke coming out of the battery.
It's a fair point. Probably shouldn't do that feature. Don't do that feature, George. It's a bad feature.
How long is the battery life?
2 hours. And it takes, we've got a 4-bank charger we travel with, and that charges batteries in normal weather about 45 minutes. So like one 4-bank charger can keep 2 robots going all day long. Unless you're in Boston and it's below freezing, in which case you have to show up with all your batteries fully charged, and as you change them through the day, they go for shorter and shorter times because batteries suck in the cold. And at the end of the day, you're getting 30 minutes per charge trying to finish out your last bay, banging your head against the wall. Not that I've done that.
So is the new robot that you said you're going to come up with going to be more battery efficient and time efficient, or just more like smaller and all that stuff?
So it's the exact same architecture. So it uses the same sensor arrangement up top to get its precision, its same kind of sensor arrangement at the base. So as far as like the autonomy software is concerned, pretty much the exact same robot. The main core of the design is more deployable by one person. Like that's the key, is that you only need to pay for one person going out to the site instead of 2. So deployable by one person, reliable by design is the way I phrase it, and that is I don't have to take apart the system to travel. It has way fewer cable harnesses. It's mostly board-to-board connections and like physical boards connecting to physical boards because those have far fewer pin issues and demating issues. It has like designed for reliability, lifetime longevity, whereas this was just to get something going. So those are more, and the aesthetic is let's produce a professional looking product to be able to get that confidence in the market. So those are kind of some of the key elements of that new design, I guess, plus the virtual bumper. It's like the one new feature that will be important. The long-term goal in 2 years-ish will be you set up 20,000 square feet at 3 p.m., you get go and you leave, and you come back and the layout's done. And that's the long-term goal. So adding enabling technologies to the next version like the virtual bumper are something that will make that possible. And that's something that our competitors cannot do. Like they do not have the infrastructure that just like the way their system is designed makes that impossible. So that's one of our long-term strategies to dominate the market, because our technology stack enables us to be fully autonomous overnight autonomy.
Why haven't you guys thought of deployable robot rollout cases? So like just a box with it and you push a button, the robot comes out and comes back in. Why have you thought of it that way instead of having the robot pull out and having a tablet set up and all that stuff?
So I find your phrase interesting. Why haven't we thought about it?
Have you thought about it? My bad, is a better question.
Yes, we have.
Yeah.
That is a problem we will solve, but not today.
Oh, fair.
Solve the important problems first. Like that one, we can buy a Pelican case it fits into. We know the ergonomics of that case suck. There's going to be pieces of transport in that case that are going to suck. So we'll eventually design our own case for it to travel in, but that's not a problem for today. That's not a problem that's going to stop me from growing the business. That's a problem that just is going to make our lives easier, make things a little bit easier versus something that's going to enable growth.
Fair point, yeah.
That's where you would implant smoke machine.
Yes, exactly. The cool video is like, it is sweet. I have a really cool photo from a project in New York that they were doing a ton of demo on the other half of the floor, so it's pretty dusty. And it was early morning, so it's just like dark with the overhead lights and dust. You see the lasers like shooting through. That's a super sick shot.
picture we used for general.
Yeah, that's exactly what it is. Yeah.
So, what do you think is the biggest trouble to production on this scale? So, is it like manufacturing components? Is it getting the capital to build the system, or is it just we need time to redesign the system to make it easy to build?
So what?
What's the biggest?
Combo.
It's a very
it's a combo.
It's all of them.
Both and.
From a technology standpoint, the hardest part of scaling is, I'm going to go back to what I said, what is zero?
Yeah.
Is building a high precision device quickly is hard. You have to be very conscious of the way you're building it to enable it to be commissioned and calibrated quickly, efficiently, and the same every time. And that is like one of the hardest parts of building many robots. Business-wise, there are challenges of, it's $50K per robot. Goal is 40 to 60 robots next year, depending on how different partnerships and stuff pan out. That some quick math is $2 to $3 million that I need to buy components. 4 to 6 months in some cases before I actually even get a robot that I can start making revenue off of. So how am I getting that capital in ahead of time? How am I paying for that? How am I guaranteeing it? There's different pieces of debt you can do. There's different partnership agreements. Like there's a lot of ways to skin that cat. And then also generating enough demand to need 40 robots is the other piece. It's a little bit of a chicken and egg problem of, I need the money to build the robots, but I need the robots to make the money. And that's the point of venture and what we're navigating. I was on the phone on the way here, poor Georgia to drive in silence as I'm listening to, we're chatting with the board, Derek and I are chatting with the board about, basically how are we going to pay for these 20 robots, what are different ways we can work with this person or that person, and strategies on the negotiations here. Like, it's literally what I was doing on the way over to solve some of those problems.
Where's y'all's Where's y'all's main base of operation? Is it here?
Yeah, work out of the East End Maker Hub, if anybody's familiar with it. It's over in Edo. TXRX in the city partnered up to build and basically renovate a 300,000 square foot warehouse. So we have 7,000 square feet over there, over a couple different rooms. We've got nice 1,000 square foot setup now with a nicer new mocap system, so we can verify ground truth and stuff. We got 24 people now. Yeah, 24. Goal at the end of the year is 27, 28. Anything else?
I'm just realizing this 70 pounds right here costs more than my car.
Yep.
You let students take a shot at driving it? Or
Yeah.
Just don't hit the computer.
So it drives like a video game. So you have forward, backward, strafe, and then twist.
You guys started integrating with the direct end-to-end construction firm? So saying, hey, this construction firm to design how to do end-to-end. So we're going to get them. Have you thought of each of those guys yet, or is it still kind of hard to think of that?
I'm new, and
stop is 20, 30 seconds, drives for a few seconds to the next point, stops for 20, 30 seconds. So that's why we're trying to cut that time to as small as possible. Eventually, get it to zero so it can just continuously move, and at that point, we win. But that's an incredibly difficult problem to solve, is closing that loop that precise and fast over those denominators.
You'll keep driving out of favor.
To be fair, framing the camera isn't huge.
No, it's not.
You can just move it back.
So I have a question when it comes to the batteries. And like, so far you guys are relying on basically workers to like replace them. Have you thought? I know Roomba does this thing where it kind of goes to a home base and then you recharge it on base. Have you thought of something like that?
Once we head towards like full overnight autonomy, that will be Mark 1 is going to be these. Mark 2 might have built-in batteries, and then we have to start worrying about battery consumption and battery size and the batteries of real Pneumatic System. Like right now, I can ship this without batteries anywhere in the world underneath the plane. I have to check luggage. As soon as I put a lithium-ion battery inside, I have to ship it away. Or special freight because of the lithium ion. So this allows some of that diversity. But version 2, version 3 will likely have built-in battery chargers.
Lasers.
The lasers are shaky. That's what's really
Yeah.
Yes.
How do you deal with that? It doesn't take measurements a lot.
Or is it good?
This version does not take measurements while it moves. We made a poor choice in the design of this, where it's actually there is backlash in that laser, and that's what you're seeing is the backlash. And that's part of it's just the way it's controlling. It's controlling very jerkily. Autonomous motion is. So it's like very smooth motion, much easier to handle. So it's a combination of the backlash in the system, which causes some of that, and the jerkiness of things that we're telling out. The new robot has direct drive, so it'll be much stiffer control.
So, printer is the reason the printer is different between we are actually so is the reason it's of interest because it's such a single line because it's able to print multiple in any direction.
It's able to print multiple area.
But you don't need a
Whereas we're providing one, a different technology, so that our robot localizes doing it, which enables it to work different go site. So it's a different technology that enables different ways that it operates. And we operate different servers.
I think everyone's taking a shot at it.
Yes, I take it. Yeah. So, are you like?
Oh, tablet?
Are you doing research for a while?
It's just a Bluetooth. He'll switch to your.
900 megahertz.
Oh, it's just transmitting.
Yep.
It's a 915 meg, so it's a LoRa system.
What?
Running LoRa, is it just running a line?
I buy this because it's safe and simplified, and I don't have to worry about it.
That's fair. You guys have what number?
Don't ask me that. I think from the first time, if you told me tomorrow, hey, I need this to be completely autonomous, go. And I focused on that. I would say by the end of next year, I would be trying full autonomy on a job site for the first time, and then sometime between 3 months and 7 years from now, I would succeed. So the way that I've mapped out development now is the first time we are autonomous, it needs remote operation capability, so remote monitoring, remote camera, like on the robot, and somebody at home. So this is transmitting back to maybe it's a 1 hertz video with the telemetry coming across, so that I can make sure it doesn't do something weird or unsafe or fix basic problems like that. Remote supervised autonomy is the right first step before we go to true full autonomy.
Have you guys thought about swarm operations, having multiple running at the same time?
No, because the way the job site works, once we kind of get to the speed goals that we're going, most jobs don't have enough space open to need 2 robots.
Valid, right.
And if it does have enough space open for 2 robots, and you really want to move things fast, I'll bring 2 robots. I'll have one work over here and one work over here as totally independent systems, and I'll charge them 3 times as much.
Yeah, because they operate independently, you don't have to load.
So the way we do it now, we do roll with 2 to hit kind of the speed goals that we're looking for from 1. And yeah, the way we separate the building is we'll finish this area, and then finish this area, and then finish this area, so that they can the same way they do it, because they want that area cleared out. So I'll have robot A do this one, robot B do this one, and have them leave from each other, so they're out of each other's way. Because solving a swarm problem is really hard.
Yeah.
Or I can just make it so they have no idea the other one exists, and I'm done.
So in the future, does that mean that you plan to make it so the robot is actually once you're done with all the automation ideas and it works technically enough, are you plan to make it go faster or something to finish the job faster? Or is this a good enough speed?
The actual physical speed of the robot is about as fast as we need to go. Like increasing that speed has small gains compared to all of the other things that make it slow today. So like if I double the speed today, I would get 5% more printing, versus if I decrease the measure calculation time by 50%, I can double the print time. So there's a lot of those problems to solve before speed ever becomes an issue. And we probably won't go any faster than this because honestly, that speed is a safety thing. Like, people get kind of uncomfortable for robots just freaking zooming around. Like a 50-pound robot just flying makes people so we definitely don't want it to ever be faster than human walking speed. That's kind of the max speed we go for, because that's the max speed people are comfortable seeing something moving around at.
A lot easier to take them down than a robot apocalypse.
Well, I think you guys' plugging expires in 30 minutes. So
Okay.
we want to all get a group photo.
Sure.
Justin, we want to go to group photo with everyone. Okay, I'm going to back this up. We can, but it's going to cost a lot.
Wait, does that thing, can that thing take a picture?
It's taking a video right now. Take a look.
Okay. Ready?
Everyone good?